In this video, I want to give one more example of solving a rational equation that in this case turns out to be a quadratic equation. So we look at the rational equation, it only has one fraction, its denominator is x plus 2. So let's start there by multiplying both sides of the equation by x plus 2. Remember that means every term on both sides in the numerators gets multiplied by x plus 2. What do we have after that? We have 3x plus 2 times x plus 2 over x plus 2 minus 2x times x plus 2 equals 1 times x plus 2. So everything got multiplied by x plus 2 here, and within this fraction, it divides with the denominator of the fraction. So now I can write my simple equation with no fractions. 3x plus 2 minus, here we have 2x squared minus 4x equals x plus 2. All right, well, we ended up with this x squared. So that's a clue. This is going to be a quadratic equation, which we can try to solve by factoring. Let's collect some like terms and reorganize this equation. So I'm going to write the negative 2x squared first, and then I have 3x minus 4x, that's minus x plus 2 equals x plus 2. If I want to subtract these terms to move them to the left side, let's subtract x and let's subtract 2. And then I have negative 2x squared minus 2x plus 0 equals 0. So here's my simplified equation. We can solve this by factoring. So let's factor out a greatest common factor. The greatest common factor here is negative 2x, and then I have x plus 1 remaining if I factor out negative 2x. This is equal to 0. So we factored the quadratic equation, and then by the zero product property, as we discussed in an earlier video, we can set each factor equal to 0. So either this factor equals 0 or x plus 1 equals 0. If I solve this equation for x, I just get x equals 0, so that's a potential solution. If I solve this for x, I get x equals negative 1. That's another potential solution. I just need to go back and make sure that neither of these are extraneous solutions, meaning they're not undefined in the original expressions or equation. The only denominator here is x plus 2, so this is undefined when x equals negative 2. That makes this denominator equal 0. If I plug in these values, x equals 0 or x equals negative 1, this denominator will be something other than 0, so these solutions are acceptable. They're not undefined, and that means our equation has two solutions. So in some cases, our rational equations can translate into quadratic equations, which we will then solve by factoring.